Hello everyone, this is Mr. McMillan, and I'm here with the final transformation video, and this time we're going to be talking about dilations. Now, if you've ever been to the eye doctor, you're probably familiar with the term dilation because at eye doctor's office, they typically dilate your eyes to better examine your eyes and, take pictures of your eyes and so on and so forth. The same type of concept is used in geometry with figures in the coordinate plane. So in a dilation, what we're doing is we're taking the pre-image and we're either making it larger or making it smaller. Okay, so we're either making it larger or we're making it smaller. So a dilation that creates a larger image is called an enlargement. And the dilation that creates a smaller image is called a reduction. Okay. Now, when we talk about the coordinate plane, dilations are generally centered around the origin. For our class, that's where they're always going to be centered. And regardless of whether a dilation makes an image larger or smaller, each one has a scale factor. So each one has a scale factor. Now, if you recall, we talked about scale factors when we were talking about similar triangles and similar figures. And a scale factor is just the ratio of two figures' measurements. Okay. Now, if two figures or two objects in geometry have a scale factor, they have a ratio that matches up with every single measurement, then that means that the dilated image will always be similar to its pre-image, whether it's bigger or smaller than its pre-image. So the first one we're going to talk about here is an enlargement. So if a scale factor for a given dilation is greater than 1, then the dilation is an enlargement. When performing a dilation, we will be multiplying each coordinate by the given scale factor. So we have to know what scale factor we're doing our dilation at, because that's what we're going to be multiplying our coordinates by. So for a given scale factor A, a dilation is going to be given by, and this is going to be our mapping rule, x comma y is going to map. We multiply x and y by our scale factor. In this case, our scale factor is A. So we take A, multiply by x, and we take A and multiply by y. So for instance, if you wish to do a dilation of 2 about the origin, then your mapping rule, xy would be mapped to, you're doing a dilation of 2, so all you're doing is multiplying both of your x and y by 2. So you'll have 2x comma 2y. So let's look at an example of an enlargement here. And here we see that we're doing a dilation of 3 around the origin or about the origin. They all mean the same thing. So with a dilation of 3, that means our scale factor is 3. And our mapping rule would then be xy maps to 3 times x comma 3 times y. So what we're going to do, we're going to write our points here. So A is at 1, -2. Going to leave some space. B is at 3, positive 2. And C is at 0, positive 3. So we're doing a scale factor of 3, a dilation of 3. So we're going to multiply each of our x and y coordinates by 3. So 1 times 3 and negative 2 times 3. So A prime, 1 times 3 gives you 3. Negative 2 times 3 gives you negative 6. So we plot the point 3, negative 6. And that's our A prime. Then we do the same thing for B. We multiply 3 by 3 and 2 by 3, and we get that B prime will end up being 9, 6. So 9, 6. And C, we multiply both x and y by 3. So C prime, 0 times 3 gives you 0. 3 times 3 gives you 9. So 0, 9. And then we just connect our points here the best we can. Since I'm not using a straight edge, I should be using a straight edge, but okay. What matters is that the points are correct. So all you're doing with the dilation is you're just multiplying both your coordinates by the scale factor. So let's look at a reduction. So an enlargement was a scale factor that's greater than 1. A reduction would have to be if a scale factor for a given dilation is less than 1. Then the dilation is a reduction. So like with an enlargement, we will be multiplying each coordinate by the given scale factor. So that's important. And a reduction will always have a scale factor that is a fraction or decimal. Okay. So for instance, if you wish to do a dilation of 1/3 about the origin, your resulting mapping rule would be, you would take x comma y, and that maps to, so you do a dilation of 1/3, so 1/3 times x, comma 1/3 times y. So even though it's a fraction or a decimal, you're still going to be multiplying by x and y. So multiply it, be consistent with it. Regardless of what dilation you're doing, you're always multiplying by the scale factor. So in this example here, it wants a dilation of 1/2 around the origin. So our mapping rule is xy maps to, and then we take 1/2 times x and 1/2 times y. All right, now I'm going to list my points down here for D, E, and F. So D is at the coordinates -4, +8. E is at the coordinates 8, +2. And F is at the coordinates -6, -6. So our dilation is 1/2. So to get D prime, we're going to take -4 times 1/2 and 8 times 1/2. And when you do that, D prime, -4 times 1/2 is -2. 8 times 1/2 is +4. So -2, 4 will be our coordinates for D prime. Then we do the same thing for E and F. So E prime is going to be 8 times 1/2 and 2 times 1/2. So E prime, 8 times 1/2 is 4. 2 times 1/2 is 1. So 4, 1 is our coordinates for E prime. And then F prime, you have -6 times 1/2. And the same thing for your Y. And you get that F prime, 1/2 of -6 is -3. So your coordinates for F prime are -3 -3. Okay. And that is dilations. Dilations are just, multiplying by the scale factor that you're dilating by. So all you're doing is taking your original coordinates and multiplying by the scale factor. So I hope this video has helped, guys. Make sure you work on the assignment for this. And if you need any help, please let me know. Feel free to email me, contact me in any way. And thanks, guys, and I'll see you in the next video.